So we wanted to kind of go over, I think, kind of two examples of some advanced XPDL functionality beyond just the how do you perform XPDL. Here's some kind of a little bit more discussion on, I guess you can call them best practices. One of them is called entity unification. This is a particular type of problem that we might face in our text. So in this text, this is going to be some sort of like auto insurance data, for example. So we have statements about what these parties are doing, the insured and claimant party. And a lot of times they refer to these parties as the insured or the claimant, but sometimes they refer to parties as people's names or what car they're driving, like the Ford Windstar was in the left turning lane. Okay. So in performing these extractions, it's easy to find mentions of the insured or the claimant because those are very common words. We can just store them in a word class or something like that. But how do we know when the Ford Windstar was in the left turning lane with a green arrow, or Aaron was not wearing a seatbelt? Because Aaron here, is a party. The Ford Windstar is owned by one of these parties, right? So we want to capture these. How do we write XP to capture them? Because Aaron won't be the insured or the claimant, specifically in every instance, right? In one document, a person named Aaron might be the insured, and another document, the person named Aaron might be the claimant. So we can't just store these words in a word class, even if we did know ahead of time where they were and who they were in one document. So this is a very contextual and a very contextual problem that requires knowledge to be imparted upon these words, to be learned. The system needs to be intelligent enough to actually see these and understand who they are in that moment, not just as a blank definition that I can apply to every single piece of text. That's the problem we have a lot of times in data. First names, last names, pronouns even, like she went to the mall. Who is she in that case? Stuff like that. So that's what entity unification is attempting to solve. That sort of co-reference problem that we as humans do pretty naturally because we are knowledge processing machines. But a literal knowledge processing machine that we build is not often intelligent enough to do that. We need to somehow provide it the necessary tools. So I'll show you how you can kind of do that with XPDL. So first of all, we went ahead and looked up or pre-processed a few things in this data. We've used the default people entity to discover the names in this text, and then we've created a vehicles entity to discover the vehicles. I won't go over this entity because that's not the point of this video. We've just built this entity and it discovers vehicles and it has attributes of the vehicle. That's just not part of this video. So now that we have those, we've pre-processed those. Those are just independent, right? So in the people entity, we take a look, we can see, Aaron, Ferdinand, Veronica Smith. Okay, all right. So these people, we found the people. And for vehicles, hopefully we've found these vehicles as well. So here we have that Ford Windstar. So that we've found the people, we've found the vehicles. We need to somehow know whether or not, or who they actually are. What party are they? And so we're going to be doing that with this unification node. Today we're focusing on just that insured party, but all of this logic we can kind of apply to the claimant party too. So let's see how we can do this. So I've created a new entity. I've called it insured. And so here's the XPDL that was used to do that. So there are going to be a few different types of rules here. Okay. The first type of rule that we care about is at the bottom. These two. my type of rule, I mean just a conceptual rule. What's it doing in the XPDL for me? Okay. I don't mean there's anything mechanically different in the actual XPDL. So we have two rules, people and vehicles, and they're just pulling the entities that we've already discovered. So this is just very simple, okay? I'm just looking at the previous entities I've captured using the entity function, so the people entity. And then I'm using toEntity to pull those attributes out. So I have the first name and last name as attributes that I got from the people entity using the toEntity function. And the same is true for vehicles. I just use the entity vehicle, and then I have some attributes called manufacturer, model, and year that I'm just pulling out directly. Okay. So these two rules are very simple. They don't really do anything right now because all this information was already captured in those previous entities. This isn't really doing anything. But it'll be capturing these as if they were insured. Now, these are going to capture all people and all vehicles. So right now, if we just had these two rules, all people and all vehicles would be labeled as the insured entity. Of course, that's not really what we want. There could be many people in a document who aren't the party we're interested in. But for right now, that's fine. We'll leave them be. Now, the second type of rule that we have here are what we call the semantic link rules. These rules are going to do this knowledge transfer for us. We know in our document that Aaron Ferdinand was the insured for some reason. And that reason is because there was some piece of text that just said it. Either it just directly said, Aaron Ferdinand is the insured party, or there was some contextual clue there that as a human I could read, understand that Aaron is the insured, then whenever I see Aaron I know she is the insured. So that semantic transfer information needs to be captured and stored in a knowledge base in the machine, just like it is kind of intuitively for a human. So these rules are going to be accomplishing that, and there's many different types of these semantic links depending on the kind of data you're working in. I listed 3 of them, but you could spend a good amount of time brainstorming and fine-tuning these. So for example, in this text we had what is called an aphora. So it's insured, comma, person. So like, I spoke with the insured, comma, John Doe. Okay, that's sort of, who is the insured? John Doe is the insured. It's sort of, that's a way in English of designating kind of membership in a class. It's called an aphora. And so I want to look for that, right? So I want to look for phrase, insured, comma, people. That's just going to be a very simple PDL. I'm returning that whole thing. I'm using the toEntity function to get the attributes of the person again. And then I'm giving this attribute. This is the kind of secret sauce of the semantic link here. The attribute I'm giving it is just a hard-coded attribute. It doesn't really matter what it is. In this case, I've said attribute insured equals yes. It doesn't really matter what you put there, as long as it's some hard-coded thing. Basically, this is just acting like a check mark. Yes, I've created. This is the insured party, and why we know it's the insured party? Well, it's just this phrase right here. That's how we know this is the insured party. Okay, and then I have other rules that do the same thing. So parentheses. So in this data, they happen to say, you know, parentheses insured parentheses John Doe. It's just a way of signifying, kind of very similar to an aphora. It's performing a very similar operation. Or they can say, or actually there was actually a snippet of text, and we'll see it later, where it was like insured vehicle colon, you know, Ford Windstar. Okay, that sort of thing is directly signifying that the Ford Windstar is belonging to the insured person. It's the insured vehicle, so whenever you see the insured vehicle, you should know it's the insured entity. Okay, so all these are just basically the same thing. Okay, it's just looking for a phrase that links these entity we care about, the insured, to the entity we are interested in, but we don't know if they're insured, like the people or the vehicles, using some logic to bring them together. I just pull out the attributes of that entity I care about, So the two-entity function on people, or the two-entity function on the vehicles, okay? And then the last thing I need to make sure I have to do, because I know these are the insured people, because this is exactly what that means. I need to provide it some attribute that hard codes that knowledge. So I used attribute insured equals yes. Okay. So this is all we have to do inside of just the code of the XPDL. Okay, but we're still not there yet, because we'll find any person and any vehicle that'll be marked as the entity insured. Then we'll find the actual insureds that are directly referred to as the insured, and they'll have an extra attribute called yes. But then all the loose attributes, all the loose instances of the actual insured entities won't be marked that way. Like, for example, we said the insured is Aaron Ferdinand. In that sentence, the Aaron Ferdinand will be marked with yes. But then we go on to say, well, Aaron Ferdinand ran the red light. That instance of that will be picked up by the people entity, but it won't be marked as the insured with this attribute yes. So we need to share that information somehow. We need to propagate that information. And we can do that with the post processors. So the post processor here that we're going to be using is the aggregation post processor. And then we're going to add in all of these attributes, including the kind of checkmark attribute, the insured equals yes attribute. That's the one that's really important we include that one. And then I always do additional searches. Alright. So that's all we need to do with the post processor. So what that's going to do is whenever we see, for example, Aaron Ferdinand is the insured. Okay, so being marked yes there. And then if I see Aaron Ferdinand down here with another, just loosely about Aaron Ferdinand was speeding. Okay, that is just going to be picked up with the people entity. Well, because the first name and last name attributes are the same here as they were in the extraction above, the attribute equals insured will be shared. Because down here, there is no attribute equals insured, so it'll just be null. So that attribute will be shared over through the post processor. That information is propagated. So all of these loose people in vehicles, if they are matched by some of these direct declarations of who they are, if they're matched by something up here, then that information will be shared across all the loose all the loose mentions. So that's how we fill in the knowledge gaps. So we're done. Almost. We are almost done. So we have all the people still extracted, regardless of whether or not they're actually insured or not. If they are insured, the knowledge propagation will have that attribute there for them. And if they're not insured, or there's no evidence that they're the insured, then they won't have that attribute. It'll be null. So let's just use that. Let's just say, all right, everyone who's not marked as the insured at this point, after we've done the post-processing, let's just throw them away because we don't care about them anymore. And that's what we do. So the filters, or where we're going to be using that. So the filters tab, we'll add a new filter. And then the logic is just make sure that that value is yes. And that's all you need to say. As long as that value is filled in with something, then we'll know that information has propagated, and then whatever we're looking at is the insured. So this doesn't, in this case I said insured equals yes, but this, this could be whatever you want it to be, as long as we can filter by it. And that's it. Those are the stages of entity unification. We created our entities that we care about, so like the people, the vehicles, those are done beforehand. Now we're going to bring them together. How do we do that? Well, we just directly call them. Those are our basic mentions. Those are candidates. And then we do the semantic linking business. We have these rules that find instances of the entities we cared about, that are linked to the entities we want to create. So this insured entity, we want to link them together. So this logic does that. We include this kind of checkmark attribute that contains that semantic information. We then use post-processing to share that information across the dataset and propagate that knowledge throughout. And then finally use filters to only let those who have that checkmark checked. Make sure we have only the ones who have been discovered to be the insured party. And that's it. That's entity unification. So let's take a look at some of the results here. So now we'll have a new entity called insured. So in this first document, we have insured Mary Bowden. Okay. So we'll have insured. So this is probably that was that semantic link there. This was captured by the semantic link. And then all the other instances of Mary will be denoted as the insured, because those are from the people entity, and that propagation of information allowed them to be checked. Now you notice there's other people called Susan and Michelle, and those are people, but they're not counted in the insured entity because of that filter step. Nothing was propagated to them, but they're filtered out. Now we have insured. An example, that Aaron Ferdinand again, we have her, okay. And we also know that she drives the Ford Windstar, because of this right here. Now, whenever I see the Ford Windstar, I know that's the insured. Not only that, but I know who owns it. Aaron Ferdinand owns it. Aaron drives Ford Windstar. That information propagation is very powerful. And just an example here. Veronica Smith. Megan isn't counted. So that's energy unification. If you break it down to its components, it's not that daunting. Just I'll have all these components and we're good to go. The next thing I want to talk about, just very briefly, is kind of using entities stacked on top of each other. We did that above here in this case, because these are very separate ideas. I had the people, then I had the vehicles, and then I kind of linked them together. But this idea of breaking entities apart, I really encourage that. So what I mean by that is here we're looking for actions regarding traffic lights. Okay, this is kind of again in that auto data. So things like claimant ran the red light, insured had the stoplight, insured ran the red light. Okay, so we have like a party, we have a light that we want to find, and then like an action that they do. Okay. And so the properties here, well actually this is what we want to find, right? The party, the light, and the action. And there's two different parties, three different lights. Right now there's two different actions. We can think of more. But there's a lot of permutations of this. You know, two parties to look for, in combination with three lights, that's 6 possible functions I have to write. In combination with another 2 actions, that's 12 functions I have to write. Or 12 PDL expressions that I have to write. That's a very simple example. It's gonna be tedious to write. So if I do that, you know, I gotta write insured ran the red light, claimant ran the red light, claimant ran the yield light, insured had the red light, insured had the green light, and do that for everything I care about. That's a lot of duplication, right? So phrase, insured, had, span, run through, span, that's a lot of duplication of the same thing. Now, I mean, you probably can say, alright, well, you know, what are you doing? Just put this in a term. Okay, I can do that. You know, put that in a term, and it's not duplicating so much. Oh, that's true. But, you know, ignoring that, the words themselves, the entire structure I'm repeating. So what if I want to change the structure? What if I want to switch to using dnode? I'm going to do that for all of these. Well, not to worry about the words themselves, the structure. So this isn't very good. Well, I mean, we can make this better. And you've seen examples of how we can do that. So here's a second version. It does the same thing in terms of the output, but it's a bit better in terms of efficiency and kind of writing it. So now let's just use some hierarchical rules. Right, so looking for the action first, so ran, and then I'm looking for the light I care about, so the red light, and then I can just do phrase 3 insured ran light, claimant ran light. Okay, so that's a bit better. But it's still not very good because like I have to, no matter what ordering I do this in, I'm gonna have to duplicate some things. So like the insured ran the light, and then the claimant ran the light. Okay, that's not as much duplication, but it still has to be duplicated. And then I had. Then I got to look for had. Then I got to look for red light and green light all over again. So no matter what ordering I do this in, I'm still duplicating a lot of stuff. And I don't like it. So my proposal is to don't do this in one entity. Split it out. So this is what I call a helper entity. The first thing is traffic lights. Let's not worry about putting it all together yet. Let's look for 3 different things. Let's look for the party, look for the action, and look for the light separately. Okay. I have a green light, red light, stop sign, so I can look for these. And then they have attributes called green, red, or yield. Okay. That's very simple. Let's use 3 different rules. I have a red light, if they have this, okay, then I'll mark that as red light. If they have a yellow light, okay, it's this, I'll mark it as yellow, as the yield light, okay, something like that. Very simple. Same thing for the action. They can ran, they can have had. Denote the different type of class by the attribute. That's kind of what we're doing here. We're creating classes, these entities. That's the whole point of entity extraction. The identification, that's not a word, of our concepts, bringing it down to the atomic components. So we have things called traffic light. Different instances of those things and different types of those things designated by the attributes. You have different actions. What kind of actions? Put that in the attribute. Different parties. What parties? Put that in an attribute. Okay. So now we have all of our different components. And then the type of component it is specifically is going to be contained in an attribute. Now, let's put them together. So, once again, this is doing the same thing for our output. It's just going to be better for our query. Wow, look at that. All in one. All I had to do was say phrase. Alright, give me party I'm interested in, find me an action, find me a traffic light. Somebody does something with the traffic light. And then who, what party, what action, and what light? Oh, we're just use TwoEntity. Okay, there you go. That's so easy. So we went from all that kind of messy nesting business and all of that, having to figure out, you know, all this duplication of code and stuff, to just a one. It's barely even a few lines. And if I wanted to make this shorter, I could have. I could probably condense this in half if I wanted to. I mean about half, but maybe a few more lines if I wanted to move this. If I wanted to move this up, you know, for example. So. That's the advantage and the beauty of stacking our entities. Do that as much as possible. Makes your life easier. You have these components that you're kind of reusing, have different types of those components, but they're kind of the same thing. Put that in an entity. That's what we're doing this for. So, in short, those are kind of just 2 examples. Kind of wanted to walk through 2 examples of some entity identification functionality and why it's so useful. Or not just identification, but just XPDL functionality. Identification was an example of that. Being able to bring these things together, unify entities into kind of one thing using contextual information. And then just, you know, split these entities up. It's going to help you when you're running. That's all we had to share in this example. Hope to see you in another video sometime soon. Thank you.